Good afternoon, good evening, or good morning from wherever you're joining us from today. My name's Sarah and I'm the Program and Event Manager at the Reactor in Sydney, Australia, and I'll be facilitating today's event as a voiceover. So welcome to another Microsoft Reactor live stream event. I'd like to welcome Sam Ronsky. Sam is a cloud advocate for Microsoft. Today he will demonstrate how to create a containerized .NET application. But just first, a bit of housekeeping. So I've put the check-in link for today's session in the comment and Q&A section with the event code 14312, where you'll find additional resources from today's session. So please do check in. We will be talking for about 40 to 45 minutes with about 10 to 15 minutes for questions at the end. However, do send us your questions throughout and we'll try and answer as many as possible where they're relevant for the topic or towards the end. At the conclusion of this session, we'll also share with you a link to our feedback survey in the comments/Q&A section. The event code for the survey will also be 14312, the same as the check-in. But for now, without further ado, I'll hand the floor over to Sam to begin. So thank you so much, Sam, and over to you.
Hello, everyone. I'm Sam. Today, we're going to be taking a look at .NET and containers. Containers are a way for you to isolate your processes and keep things contained within themselves. What this allows you to do is create reproducible instances of your application and redeploy it in different places and recreate it without having to reconfigure your server or do any extra steps in order to make the platform work for you. It's sort of a way of creating these composable pieces that you can just place where you want them, whether that's in the cloud or on your own computer, and run them. So what we're going to be doing is creating a really basic .NET application. We're not really going to be focusing too much on how to write .NET or how to create the application. What we're going to be focusing on is how do we create that container and what value do we get out of creating that container. So we're going to kind of take this in steps and do a lot of demos. That's, I think, the best way to show this. So what we're going to start with is just creating our basic .NET app. So we're going to just start in this empty directory here and do a .NET new and just create a web app. So web is what we want. You can put anything here. Again, we're just containerizing a application. The application doesn't really matter in this context. And so I'm going to give that a name, and we're just going to call it our Containerized container thing. .NET, sure. There we go. There is our template that should create that, and we can just open up a Visual Studio Code instance for that. Like this, and we should get a instance of Visual Studio Code running that will kind of have our application for us. So this is all the fun stuff we just created. We've got our code over on the left here, and really all this application does is create an endpoint for us to ping and receive hello world back. We should see that in here. So we have one endpoint that just writes hello world out to us. So what we want to do is just kind of get this running. And so we're not doing anything with containers yet. We haven't really worked with them, but all we're doing is just creating this application and running it. So we do .NET run in our application. There we go. And we get this application running. We will get a build. It should automatically build for us, and we'll see that we get this local host on ports 5001 and port 5000. One of them is the secure port, and one of them is not. We're just going to be using port 5000 for this demo. And then I'm going to open up Nightingale. This is just a Windows application for creating REST requests that's actually going to go out and ping whatever service you want. You don't need to use this. You can use Chrome or Edge or whatever web browser you want. It's going to do the same thing. This is just sort of a more programmy way of doing that and lets us send these requests to our service, and we get back a response. In this case, we get hello world from our server, and everything seems to be working fine. And so that is our application. We can just stop that. It's good. Everything's great. Now, we actually want to put this in a container. The advantage of putting this into a container is that we can actually recreate this over and over again without having to worry about the configuration. My computer is configured differently than yours, and a server might be configured differently. What we typically want to avoid is a server that is designed specifically for that application, because then if that server has issues, you're going to spend all night recreating that server, and that's no fun for anybody. And so what a container allows you to do is kind of define what that server is and what should be part of that. It creates this isolated set of, what's the best word for this? File system, I guess. It creates a file system and network that is somewhat isolated and defined for that container. So the specific configuration for your machine is not interfering with that. It's sort of helping you avoid that works on my machine problem. So what we're going to do is sort of start the process of creating this container. We're going to take this in parts and kind of look at the different parts that we can do in order to create this container. So what we're going to do first is publish our .NET application. And so what this does is create sort of a publishable thing that is sort of an artifact that we can actually run as our server. This should prevent us from having to do .NET run to get this thing working. So we're just going to do .NET publish and publish this to our publish directory. And we're just going to, what am I doing? Not that. Never mind. Sorry, my notes are wrong. Anyway, we're going to publish this. This is going to create a publish directory. If I open up Visual Studio Code here, we now have this publish directory, which has a whole bunch of code in it. The .exe is sort of what we're looking for. That is our Windows binary for this application. What publish does is it runs through .NET and creates a binary for you on whatever architecture and runtime you're targeting. In this case, I'm on Windows, so this application is targeting a Windows environment. So what we can do now is just run that. So we don't actually need to use the .NET command anymore. We can actually just go into publish and do our dockerized .NET.exe. We're going to get our same web host. This is also running on port 5000. I'm noting 5000 because this is actually going to change in a bit. So if we open up our Nightingale again and send this request, we're still going to get hello world. I should probably be showing that it's down in between, so it doesn't look like any tricks are going on, but that's what's happening. If we stop that server, this request doesn't work anymore, and we just get a timeout eventually. So that is our basic, I guess, published application. What we want to do now is put this into a containerized environment. So we're going to start the process of containerizing this. Containers are built on a series of layers. There's two real big components to this. There is the container image, which sort of defines a blueprint of what that container is, sort of something that you can reproduce. And then there's the container itself, which is what is the running instance of that container image. And so what we want to do is create a container image or a Docker file that is actually going to define that container image. And then from that Docker file, we can create the image and use that image to create additional containers so we can reproduce our .NET application. So let's start that process. What this looks like is creating a Docker file. Docker file is not the specific name that you need to use, but it is the most convenient. It's sort of what the Docker program expects. We're going to be using Docker for this. There are multiple different container runtimes and different ways you can interact with containers. Docker is by far the most common of these, but you can use different things if that's what you want. In this case, I'm using Docker for desktop on Windows. And there's a few considerations there. On Windows environments, there are actually two different things that you should do, or that you can do. A Docker container can run on either a Linux or a Windows environment. So if you want IIS and all of the Windows stuff, you need a Windows container for that. Whereas if you want Linux systems and environments, you need to be running in a Linux environment. We're going to be building a Linux container because those are typically what you want. They're also typically going to be smaller. So that's what we're going to be looking at. If you're on Windows, the way to check this is to open up your Docker desktop here. Sometimes this takes a bit. And check the list here. So this is going to switch us to the Windows containers. That means we're currently in our Linux environment. You can check this from the shell as well if you prefer. I just find that easier. So our Docker file has a series of layers. These are going to be sort of in Docker's language, and it's a fairly declarative way of doing this. So what that allows you to do is sort of define a source image that your container is going to be built from. In this case, we're going to be using a default .NET or the ASP.NET runtime for this. What we need is sort of something that has .NET, so we can actually run our ASP website. So what we're going to do is create a from here and run mcr.microsoft.com. This is our container registry. The container registry contains a list of these images, so these compiled or built images that you can reference later. And then we're going to look for a specific tag, which is .NET, ASP.NET, with a label or a tag of 5.0. And so this is sort of our final tag. There's a number of different variables here. You can see it's kind of separating these into 3 different things for us. We have our container registry, our base image, and then the tag that we're using. The base image is going to be sort of the image that you're referencing. In this case, we're referencing the ASP.NET runtime image, and we're using a specific tag, in this case, 5.0. What that means is that we're actually referencing version 5.0 of this specific image. There's many of these. The default is going to be latest. You almost never want to use this because if you're using the latest image, a lot of the issues that you're going to run into are going to involve what's the word? A lot of the things you're going to run into with latest is that it's going to no longer be reproducible, because if the upstream version changes, if the image that you're relying on is updated, that latest version is also going to shift. And so what you were building no longer produces the same thing, which means that the code that you have no longer produces the same thing every time you run it. Even if you make no code changes, just rebuilding your application can produce a completely different result if you're using the latest version. So typically you want to pin this to a specific version. We're going to use 5.0. And then from there, we're going to set a working directory. This is just going to be, whoa, I'm missing my keys. There we go. So we're going to set up a working directory. This is just the default working directory inside of your container. And we're just going to use app. And then we need to copy over some files. So these are weird. What copy does is actually takes 2 arguments. It takes the left-hand side, which is on your local machine. In this case, we're going to copy over our published directory, and we're going to put that into our working directory. So just use a period. What that does is take everything that is in this published directory over here and puts it into the container at whatever location we specified. In this case, it's just going to be in our app directory because that is our working directory. And then we want to set a command that we're going to run. In this case, we're going to run .NET. And then the next thing we're going to do is set up an entry point. So the entry point is sort of a argument that you're passing into that command. In this case, we're going to pass it in our Dockerized thing. The problem with this is this isn't going to work. Remember how I said that we were building for our current language and runtime? We just built this for Windows. We don't have a Dockerized application. We don't have a Dockerized binary. It doesn't exist. We have an executable that's designed to run on Windows. And so even if we run this and create this container, what we're trying to reference doesn't exist and won't work. And so what we actually want to do is rebuild all of our published parts. So I'm just going to delete this. I find that this is the easiest. And republish this so that we actually have something for Linux. So what we're going to do is go back to our publish and add a few things. So I'm going to specify the runtime, in this case, Linux on x86. And we're going to set the self-contained to false. That's just for my benefit. And that should change what we get. Or break. What did I miss? There's no application host available if it's specified runtime environment. Okay. Weird. This is new. All right. Let's do interesting. This part's not familiar to me, so I don't actually know what's going on. This was working previously. So we're in a weird spot, but okay. 86. Okay. I'm not entirely sure what's going on, so we are going to move a little bit further forward. But basically what we need to do is publish this for Linux because this binary is not going to work. So because this doesn't actually have any of the Linux stuff, so let's just go back here. There we go. Because this doesn't have any of our Linux stuff in it, .net.exe, this isn't going to run. It's the wrong environment. What containers do is work very similar to how a virtual machine works, but they're very different. Both of those systems are intended to somewhat allow you to subdivide your computer systems. So it allows you to take a server and run multiple things on it in isolation. A virtual machine is going to virtualize most of your environment. So it's going to provide you virtual hardware and virtual lots of things. A container doesn't necessarily remove or do all of that. A lot of the hardware is still shared, and the kernel is also shared. So for example, running Windows and Linux together typically isn't a thing that you could do very easily. So this just isn't going to work for us. What this is going to do is break. And so we are going to actually run that just to see what happens. I'm not entirely sure because I didn't build this into the demo, but it'll be cool because it will show us that this isn't supposed to happen. We're actually intentionally not getting to this point. This is not intended to work. A big part of this is actually showing a better way to do containers. So we're going to get to that in just a sec. So what we're going to do is actually build this container. So if I look at what's in my directory, we have a Docker file here. Docker file is a special name, capital D, and then Docker file. And that is your special file name. That is going to actually run your code. If you use a different name that is not at the top level of your directory, you will need to specify that explicitly. Otherwise, it's not going to find it. This is also going to define the context, the build context of that container and what is built. When we were copying files over, we can't go up directories to pull files in from all over your file system. It's just things at this level and down. So what we're going to do is just build this. And we can just run docker build. I'm going to, let's actually not tag this and just build this. So docker build and then a period is just going to give you the current directory. So we're saying build the current directory. It's going to find the Docker file and build it for you. And then you get a whole bunch of things. So we get the ASP.NET 5 that gets built. And you can see each of the different things that we are building is coming from a different layer. Docker files are very similar to ogres. They have layers. And so each layer is an individual part of your container. And so what Docker is going to try to do is optimize what it's doing so you don't need to constantly pull in all of the things that are changing with that file. So as you're introducing ASP.NET, we actually can pull that in. That is our first layer. Our next one is our copy or publish. And we have our work directory here, which is cached. You can actually see some of these have been cached on my system. You might see some of these take a little bit longer for you because you have not run these before. So you can actually see a little bit of that happening here. In the end, we're actually going to get some SHA out, this fun long string that is impossible to remember. This is our image. That's what we built. The problem is it has a really hard name, and we need to reference that. So what we're going to do is try to run this, and we're just going to do .NET run. There we go. We're just going to paste in that SHA and run it. This is not going to work. So that fails. And the best way to check if your thing is still running is to do docker ps. That's going to show you a list of all the running containers. In this case, there aren't any. It didn't work. And so I don't know why we didn't actually get a failure here or failure message, but that container does not run. And so the problem is we do not have a working executable. It did not work. So what we're going to do instead is actually build our source code as part of how we're building our container. And so what we can do here is create what's called a multi-stage build. A multi-stage build is actually a way to do multiple things in your container and sort of discard parts of those. So effectively creating working environments that are used to sort of set up and scaffold your final container. In this case, we want the .NET SDK so we can actually build our Docker container, but we do not want the complete .NET SDK when we're actually deploying and running our application, because that is just too much. You don't need to constantly be able to build your entire application and have all of the .NET SDK available to you as you're trying to just run your application. A big part of this is trying to keep our images as small as possible so they're as fast as we can get to deploying them and moving them around, because we're trying to get these into the cloud where we can actually kind of shift them around and do things with them. So that's what we're going to be doing now. Docker multi-stage builds in Docker can get complicated, but they can also be very useful for this. So this is the example that you sort of get if you click the add a Docker file in Visual Studio Code. This has a whole bunch of different layers to it. We're not going to be getting as advanced as this, but hopefully we will cover all the things that are used here so you can understand them and kind of figure it out. Each of these separate blocks is a separate stage in that multi-stage build. Eventually, we're getting to this final image that is just running the published file. That's what we're trying to get to. But during this, there's also an SDK here that is being used to run and compile and restore your dependencies so that you can do all of the things you need to actually build your application. So that's what we're going to be working on right here. Let's open this. And this is our basic image. What we want to do is keep most of this. Instead, we're going to be expanding this. We're going to actually be pulling from the SDK, which is a separate image, so .com or .net/SDK. And we want to match our version, so we're going to do 5.0 here as well. And we're going to give this a name. In this case, we're going to call this our build stage. So if we just do as and the build, I'm going to capitalize this just so it's a little bit easier to find. And that gives this a name, which we can reference in our future images here. And so, so now what we want to do is kind of configure this very similarly. We're going to set up a working dir with the source and just sort of create a place for us to drop our source code. And then there's sort of two parts to most .NET applications that we want to develop. And so what we're going to do is create a csproj file. There's two, I guess, parts here. There is our Dockerized.NET CS project right here, and then there's our actual code. What we want to do with these things is create layers that do not need to be recreated if they do not need to. Typically, when you're creating a .NET application, you will add dependencies from NuGet or things like that, but you'll do that a lot less frequently than you will when you are actually compiling and running your code. And so in this case, what we want to do is actually copy over a CS project file and restore all of our dependencies and then copy our source code over and build that. What that's going to do is mean that as we make changes to our code, we don't need to constantly be re-downloading dependencies every time we rebuild our container file. So what that looks like is a copy command that is going to take our Dockerized CS project file. We shouldn't need these, but my notes have them. So anyway, I'm going to delete them because what could go wrong? And then we're going to add that to our source directory. So what this is doing is taking our project file, copying that over to our container, and then we're going to run the .NET restore command. Now, we don't have any dependencies, but that's fine for this. This is just more good practices. This is sort of what you want to do when you're restoring these things so that you do not have those. So what this does is restore our .NET container and get everything running. And then what we want is to actually copy over everything else. So we're going to use the ... syntax. So from our source, we're just going to take everything on our local computer and copy that over to our build. And then we are going to run our publish command. So .NET publish our release. And we're going to publish that out to our app publish directory. And so what this is going to do is build a release copy of our binary that is published out to this directory. One of the common uses for multi-stage builds is that you can actually have a build that has debugging symbols and one that does not. So in this case, when we're publishing a released build, it is optimized for release. There aren't going to be as many ways to debug this as if we were working in Visual Studio and trying to attach a debugger. So you can actually branch this off if you wanted to. You could take this build and move it somewhere else and maybe split up this into multiple different stages. We're not going to do that because that's just extra work. But that's sort of one of the use cases here is we're creating these staging containers or images that actually can do some work for us and then get out of the way and sort of eliminate themselves so we can only use parts of them further down the line. In this case, we're using them in our final build. So this creates a published app. So we're going to run through this, publish this, and actually get this running. And so from there, we actually need to work on what's actually going to run this. We've done most of this work already. Well, the only difference now is that instead of copying this from our local directory, we want to actually publish this or run the published version that we created in this staging build. So we're going to use the from command. What this does is pulls it from whatever your name is. So in this case, build. We're going to grab this from our build, same name there. And then we need to grab it from that directory. So wherever we publish this, in this case, app publish. And then we just need to drop that again into the same directory. And then the way we run this is the same. My notes have different things, so we're going to fix this a little bit. This should be dockerized.net, and this should also be dockerized.net. On Linux, we don't have extensions for what we're running, so it should just be published. And so we're just going to save this Docker file, and that should be everything that we need in order to actually run this. So if I go back here, I know we did a lot there, but if we run this Docker build, we're actually going to get a bunch of things happening now. And so you should see multiple things going on. We're going to see a few SHAs get dropped in that are kind of intermediary images. And eventually, we're going to get this one out. I didn't tag it again, so we're still stuck with just using the SHA. You can tag things. You should probably want to tag things because otherwise you're just going to have all these images lying around that you don't actually remember how to reference. But this is perfectly fine. It works. So everything's good. It's just not super clean. So this is our final results. We get all of these. You can see each step that gets run. We actually have our copies and our publishes. Everything gets done. Then we can copy our SHA and actually run this. So we should be able to do a docker run and just run this command. And we see we actually do get all of the same things that we were seeing if we ran our original .NET host. Now we get into the fun container bits of all of this, the things that actually make Docker pretty cool. We're running on port 80 now, and that's that. So I should just be able to change this and hit port 80, and it should work, except it doesn't. Docker does isolate your application, which means that the file system is not the same. What we're seeing here is our .NET file system and our .NET application, but we're hitting my computer, what's running right here. And that is not exactly the same thing. So it's not actually finding any of the stuff that we want it to. Our request went to my computer and stopped. What we need is something that bridges the connection between our local computer and the Docker container that is running, because the networks are actually separate. They're isolated from one another. What this does is prevents you from having some application. If you have two containers, one writes something to the file system and another one gets interfered with in some way because the file that it depended on was changed. Because the containers have separated file systems and separated networks, they don't interfere with each other unless you let them. And so what we need to do is to stop this because this isn't going to work. For whatever reason, the interrupts don't work when I do this. So we're going to do this fun way. What we're going to do is just stop this. So Docker stop. And we're going to use the fun name. Docker gives all of your containers some fun name for you to use. In this case, I'm using Jang. There tend to be just random words, but it works. You can also see there's a short SHA that is a shortened context for both the image and the container ID. We can reference those later. So I just stopped that with the name, and it's done. But we can actually restart it if we want to using the SHA. So this is the shortened SHA for that container. And now we have a running container again. So if I go back here, Docker PS, it's running again. And so we'll stop this circle and be done. But that is our container starting and stopping and running, whatever. The problem with this is we can't really use this. That container does not have the port mapped that we need it to have mapped. So what we want to do is add a mapping for this. In this case, that looks like this. So I'm going to jump back here, get back to our run command. We're referencing this long SHA. We need a parameter here. We're going to do -p and then the port on our host machine that we want to map. We were using port 5000 before, and we want to map that to port 80 inside of the container. And so if we run this, we'll get a different SHA. You can actually see it there. Still on port 80 inside of our container. That hasn't changed. But now, if I go and attempt to ping this from port 5000 on my computer, Docker is going to see that request on port 5000 and forward it into our container, bridge those connections so that we actually get hello world from our application. And if we go into this, we should have seen a request come in. I don't know why we didn't. That's weird. Okay, weird, but that's fine. We should still see this running. So we still have everything running. It's now called Stupefied Mininsky, I guess. Weird names. This is why you name your things, because if you don't, Docker is going to give you weird names. And so now we're going to actually make this useful. This is a running container. The cool thing is this means that we can actually redeploy this pretty much anywhere, and it should just work. The downside is we have these weird names and we can't really reference this. It's not actually going anywhere. It's not that useful. So what we're going to do is kind of revisit this. But first, we want to stop it. Let's grab that SHA and just stop it. There we go. Our Docker container has been stopped. There we go. Cool. All right. Now, let's go all the way back to our build. This is where we were at. We had our build, but we probably want a little bit more to go on here. What we want to do is give this a name, something that we can reference. When we were building our container in the Docker file, we were referencing the .NET SDK and .NET ASP.NET and giving it a tag. Things that are useful so you actually know what's happening. Typically, you want to version your applications so that when you're releasing a new version, you can roll back if you need to the old one. Otherwise, we're just constantly overwriting everything. So that's what we're going to do here. We're going to build this and give it a tag. So the way you do that is you add a -t and then give it the name that you want. So let's just call it Containerized.net. And so I didn't give it a tag, but we rebuilt everything. Because none of the code had changed, most of this was cached. So you can see all of these things are cached, which means that Docker isn't rerunning all of this. This is why we separated the CS project from all of our source code, so we could take advantage of this caching so we weren't constantly pulling those things. And so that is our build. But now we actually have something that we can reference by name. So if I do a Docker run, and we run Dockerized.net, Now we actually get the same thing. I didn't add a port, but that's fine. Well, this way we have a name for it. So we can actually not pass around all these random SHAs that we're never going to remember because they're really big and really long and just a bunch of like password nonsense. So this is a little bit more useful for us. This is actually something we can use. You'll notice I didn't actually add a tag to this. There isn't a latest or a version. The default is going to be latest. So if we look at this, we should see it's running, and now the image has been changed. So we no longer have a SHA for our image. Instead, we're actually referencing that name. And so that's helpful. That's sort of the next thing. Can Docker be run on a bare metal? Yes. I might not be the best person to answer that. But there are a number of runtimes, and there are different ways that Docker runs. There's a lot of different components that actually make up what containers are doing. Containers themselves are an integral part of Linux. They're actually built into Linux itself. And so a lot of what Docker is doing is sort of providing you some very nice features around that. So Docker itself is just a CLI tool. There's also a Docker daemon that is actually in charge of running your containers. And there's different parts of that that actually are used. There are different tools that you can use to kind of do different parts of this container thing, because there's actually a lot going on. There's things that need to handle setting up and isolating your processes. There's things that need to handle the runtime. So this is just sort of collecting all of it into more of the parts that you can actually interact with. But if you want to set this up on your own server or do something like that, you definitely can. Docker PS, we are tagging this with images. Cool. So we have our image tagged. What we want to do now is sort of expand this so we don't have a vigilant Babbage running, because I don't know what that is. That isn't actually useful. If I saw that running on whatever production server doing something important, okay. I don't actually know what that would do. So let's give it a name that is actually useful. So first, let's stop it. So I'm actually leaving a lot around here just by the nature of doing this. There are two different things that are going on. I'm stopping and starting these things. That might not be what you want, because every time we start this, it means we can restart it. Just because it's stopped doesn't mean it's gone. Typically, the advantage that you get from containers is that you can create and then recreate them very easily. They're typically intended to be stateless applications. And what that means is that you aren't storing a lot of data. You're not storing a database inside of your container, because everything is isolated. So what that means is that if we were to create and then destroy this container, it's gone. And so if you wrote a bunch of passwords and usernames into that database, and then the container went away, all of those passwords and usernames and data are gone. And so typically what we're trying to do is sort of create something that is more resilient to that. And that's sort of the advantage here. So it's sort of a change in how you think about applications, because a lot of this is intended to be stateless. If you have one server that you're sort of treasuring and hoping stays around, containers are going to kind of skew that, because there's ways to do that, but it's not always what you want. So that's our container. It's stopped. Let's actually do the thing that I was talking about 5 minutes ago. All right, cool. Docker run our Dockerized.net. That's actually running our thing, but we want a name for this, and we want a port. So let's do that. First, let's expose our port. So port 5000 to port 80. And then let's do a name for this. I believe the tag for that is just name, but I could be wrong. For whatever reason, I didn't think that was worth making a note about. Anyway, let's just call this container.net. Sure. Now let's run that. I think this should just be fine. Yeah, here we go. Cool. So there's our container. It's running. Everything's good. If I do Docker PS, now we see it running. It's gotten very long, but that's fine. you can see a lot of information that's actually going on here. So in this case, we can actually see the ports that are being mapped. So we have my machine being mapped to port 80 on the machine. We have the name, which wrapped here, but it's container.net. We also have the SHA for that container, and then the image that we're referencing. We also have the command and when it was created and what the status is, things that you might want to know. So it's running. Can we actually interact with it? Let's send out a request. We get hello world back. It's all good. Now let's actually take a look at a little bit more of what's actually going on. Like, we've been running these containers, that's cool, but is it actually that useful? Maybe is the answer. So we've been running these things, that's great, but what is this actually creating for us? How do we actually use this? So in this case, we want some images. So Docker images. That was a weird transition. Anyway, Docker images is going to list all of the images on your machine. In this case, we have a bunch of things from Kubernetes, Redis, some Docker stuff. We have a few of the images that I've been sort of playing with. The one we just built, so the Dockerized.net, is sitting right here. It is 206 megabytes, which is relatively large, and it was created 13 minutes ago. So these are sort of how you can look at what is available on your machine. If you would prefer a more visual thing, Docker Desktop provides this. This experience is going to change a little bit depending on what platform you're on. I believe it's available on Mac and Windows, but not Linux. And it's going to give you this images list, which looks the same, but is just more graphical. And it actually has some things to run it. That's fine, great. Anyway, this is a list of all of your images. The other thing that's kind of useful is a list of all of the containers. Remember, we created a whole bunch of them. So if we look here, we actually have all of these things. So we don't just have the one that is currently running. We actually have the ones that were previously run throughout this demo that we can actually look back on and rely on. And so what this is giving us is sort of a list of what have we created, what is useful, what have we done, and how can we rerun this? So what we can actually do at this is actually take some of the names, for example. So we could use container.net, that's the one that's currently running, or we can grab a previously run one and just run it again. So if you want to do this, run .net when I'm in right Docker. Anyway, we're just going to restart this. This should break. It might break. Okay. The ports, yeah. So the ports weren't mapped, so that's fine. I was under the impression that that one had, but anyway, that isn't really the, I guess, important thing. But you can rerun as many of these as you want. So in this case, we now have two versions of our Dockerized.net container that is being run in our environment. One of them doesn't have ports mapped to it, so you can't actually access it, but we actually can. So there's some fun things that you can actually do with containers that go a little bit beyond this. Some of these things you probably don't want to do too much. There are certain things where it's okay to do them, and there are possibilities for you to use them to debug, but you probably don't want to rely on them because, again, containers are, they can disappear. That's sort of the value of them, is the fact that they can be created, destroyed, and recreated very easily. What that means, though, is that you shouldn't rely on configuration that you might make to them sticking around. So, for example, we can take our containerized.net application and exec into it. So Docker, I believe it's exec IT for interactive container.net. And let's run. Cool. So what I just did is exec with an interactive terminal running bash inside of our running .NET container. So now we have a terminal inside of this container. This is useful if you want to kind of poke around and see what's actually happening inside, because you might not know. This is what our application looks like. So we can list all the files here. Here's our published directory. It should look like what we expect from a published directory. here's the thing we're actually running, our Dockerized.net thing. I don't know if this has curl. It does not. Okay. Okay, cool. Whatever. That's fine. But you can actually run applications here. That's fine. But if you change things here, that's only going to affect this container. And a lot of the times we're going to be recreating these containers constantly. There we go. Cool. So we're recreating these containers and able to run these things and kind of do anything we want to create and run these containers. As these are created and modified, though, when they're recreated, they go away. So I've said that a few times, but we're going to remove something from this. So let's break things. That's not going to work. There we go. Cool. So we just deleted a file from this container. Now, if we exit that, we would expect that file to continue to not exist. The problem is we only deleted it in this container. So again, everything is kind of based off of this base blueprint of an image. And so even though we've destroyed that and kind of gotten rid of it, if I stop these, and so we stop both of these, and then if we try to rerun something, so let's, oh, there we go. Different place, cool. So let's give this a different name. Let's call it container, actually, probably could give it the same name. That's a different demo. Container net, cool. So we're going to create another container, call it container net, and that file that we deleted, it's there again. We've recreated this entire thing. And so the important part here is changes that you make are they're going to disappear. They're going to exist and then not exist and then exist and then not exist. That's sort of, I think, the main important thing for this. The final thing that I kind of want to cover here is that you can actually look at the logs of some of these stopped containers. So if we do a Docker PS, I think it's all. There we go. Here's our running container. That didn't do what I wanted. There. So here's all the containers that I have run that I have not cleaned up because that's what I do. So let's look at our container.net. Logs are just standard out. It's what's been happening if you have like compile errors or different logs that you need to check. This is probably the first place that you can go to kind of figure out what's going on. So if we want to look at the logs for that, we can do Docker logs and then give the name or the SHA of that container. In this case, we're on container.net and we get all of the logs for this. This isn't the application running. This isn't it actually doing or executing any code. All this is doing is giving you the standard out from that container so you can actually see if there was an error, what happened to it. This is particularly useful if you have something that is intended to run something very fast. So like we had our build image that ran a build. You can use this to actually look into that build, for example, if there's a compile error, because that isn't something that's going to be sticking around. It's not going to run and then stay there. It's going to run once and then be gone. And so you want something that can go back and look at those. And this is how you would go and look at something that has already been stopped, that is done and finished. But that is, I think, the basics of getting started with containers. That kind of covers a lot of how to kind of get introduced into this and how to kind of explore these. A little bit of a hiccup there. I think people had pointed out that I'd used x86 instead of x64. And that is my bad for mistyping the runtime. But that actually does work, I swear. Anyway, this is, I guess, an intro to containers. Hopefully this is enough to kind of get you started and get you interested in using these. There are a lot more things that you can use with this. So yeah, I think we will jump into questions if there's any questions.
Great, thanks, Sam. So we just had one question come through from Learn TV, and I just put that up on the screen for you.
Yeah. So when you're talking about running things on bare metal, there's a lot of, it gets weird. Yes, I think the general answer is yes. Containers, I mentioned this before, but containers are part of your operating system. If you're running Linux, containers are just a feature of Linux. And so that you don't require a lot to actually get them working. But there are different components that kind of orchestrate this. And so you would want something to do that. I guess it depends on what you're talking about with bare metal. You don't need any fancy like cloud server in order to run a container. You don't need Docker Desktop in order to run a container. Those are kind of tools that make it a lot simpler for you. They make it easy for you to access. But if you want to go through the work and sort of set that up yourself, you definitely can do that. I think a lot of like Kubernetes clusters are in the end kind of running things in that way. They're giving you a way to run containers at a closer level to that. There are ways to kind of trim down your containers as well. We were talking about file size. I think the one that I'm working with is like 200 megabytes. There are different images that use different base OSs that are much smaller. Alpine is a very popular one that is much smaller typically than most normal containers that you might pull like Ubuntu. So you can kind of play with those too.
Great. Well, we'll give everyone another minute to send through any last minute questions they have. In the meantime, just a reminder of that check-in link for today. Just putting that up on the screen now with the event code 14312. And we also put up a link to the survey with the exact same code, which is the 14312. And then there is our YouTube channel as well. So this one will be available on the Microsoft Reactor YouTube channel straight after today. So if there's anything that you missed from today's session, you can refer back to it from the demo and reference it that way. And also we've got any of our upcoming events. If you'd like to sign up for anything else, you can go onto our global page there. And we also have our region's local meetup pages, which will direct you to as well for any local events and also the global ones. We haven't had any other questions come through from Learn TV, Sam. So it appears that you've answered all your questions today during your demo. So thank you so much for joining us at the Reactor. And thank you to everyone for tuning in and interacting with us through the questions. We'll see you next time for another Microsoft Reactor live stream event. Have a good rest of your afternoon, evening, or morning. Thanks, Sam.
Thank you.